Well, I think the objective of our curriculum is not to prepare people for one particular job, because you're gonna get a degree and you're gonna have lots of skills that are very useful, and your job may change though in 2 years or 3 years or 5 years or whatever it is. And just because technologies keep developing and you need new sets of knowledge in order to do those things. But what we tried to do in the electrical engineering curriculum is we tried to present the basics that will not change, the fundamentals. And so, for example, the signals and systems class, the 3500, that is the kind of a cornerstone that provides you a lot of tools to analyze signals, time domain, frequency domain, deal with concepts about energy and filtering and sampling and all of these things that happen in a huge variety of communications, controls, signal processing, all sorts of computer systems, and so that is the fundamental course. That and the probability and statistics. So I think it's 35, 30?
30.
So 3530 is also a fundamental course, that everything that we deal with has noise in it. And even things that don't appear to be noisy to you, like email, for example.
Mm-hmm.
So when you have a spam filter, that's looking through text of email and trying to decide whether it's spam or not. And you probably wouldn't think of your text and your email as noise, but what we do is we study the statistics of what in general what random variables do, and it turns out that an email is somewhat random. The words that you use are random. Who gets addressed, or to whom the email gets addressed, is random. Whether or not there's an image in the email or not. And so even when you don't really think of something as random, you can look at it as random from the perspective of your system that's operating, that's trying to decide whether something is spam or not. And so the better that we can model and understand the statistics of email in this example, then the better you can build a program that's going to more accurately figure out what email is spam and what is not. And so 3530 gives the introduction into that background. So those two courses are the basics. Then I think, also for controls, let's see, there is a 3510 introduction for feedback systems, and a lot of the things that we do are controls. So not only do we have sensors on our cars that tell us when our tires are sliding, they also control the wheels and decide when to apply the anti-lock brakes and how much. So all those things, 3510 provides this mathematical framework to decide whether or not something is stable or not, and that's really critical. So those three, I think, are the fundamentals. And then the higher level courses: digital signal processing, 5510 random processes, let's see.
Wireless communication.
Yeah, wireless communications, certainly for the broad understanding of wireless communication systems, that's critical. The digital communications, if you are going to be designing digital communication systems, then you need the mathematical foundations that you would learn in 5520. So those are maybe the higher level, senior level courses.